Let us analyze the graph from the knowledge of differentiation and integration. This is xt graph, and we have seen instantaneous velocity equal to dx by dt. This is the slope of tangent drawn to the xt graph at particular point gives you instantaneous velocity. Average velocity, it is delta x by delta t, that is slope of line joining 2 points on xt graph gives you average velocity between those 2 points. Here if you observe this xt graph, what you can understand? Here when t equal to 0, some x naught value is there. That means initially the object is not at origin. It is at certain distance from origin, and from there onwards it starts its motion. Now if you take tangent at different points, it is along a straight line, it is along the same straight line, so slope of all tangents are equal. We know that slope of a straight line is the same if you select these 2 points or these 2 points or these 2 points. That means instantaneous velocity at each and every point, at each and every instant of time is constant. That means it is moving with uniform velocity. It is moving with uniform velocity, and it is positive. The slope is positive because it makes an angle less than 90 degrees. So tan theta is positive. That means its motion is along positive x-axis. Now as far as average velocity is concerned, if you consider any 2 points and if you calculate the slope of line joining those 2 points, we will be getting the slope of same straight line. That means average velocity between any 2 points or 2 times is same. So for uniform motion, average velocity between any 2 times is same, and also it is equivalent to instantaneous velocity at each and every point. So we say that it is in uniform motion. Simply from the knowledge of vectors, we say v bar is constant. V bar is constant means what? Velocity vector is constant. Vector has both magnitude and direction. That means magnitude of velocity is constant and also its direction is constant. Then we say that it is in uniform motion. Now from this graph, what you can understand? Here when t equal to 0, x is 0, that means initially it is at origin. Now instantaneous velocity v equal to dx by dt. So at particular point time t, if you draw a tangent to the graph, slope of that tangent gives you instantaneous velocity at that point, and slope of this tangent gives you instantaneous velocity at this time, and slope of this tangent gives you instantaneous velocity at this time. So if you observe this theta 1, this is theta 2, so theta increases, so tan theta increases. Tan theta gives you slope of tangent drawn to the xt graph at that point. Yes, so slope is going on increasing, so instantaneous velocity also increases. Instantaneous velocity increases, that means magnitude of velocity increases, so speed increases. One thing. So here instantaneous velocity is not the same as here, so non-uniform motion. One thing we can conclude. Second thing is, as far as this particular motion is concerned, its velocity gradually increases. Here positive, here also positive. Okay, no problem. That means its motion is along positive x-axis, one thing, and its velocity magnitude gradually increases. Its direction is not changing, but its magnitude is increasing. So velocity value increases. Next, here velocity increasing. Next, let us talk about average velocity. Average velocity means, suppose if you consider these 2 points. So slope of line joining these 2 points gives you average velocity between these 2 points, right? Now slope of line joining between these 2 points, gives you average velocity between these 2 points. So average velocity between these 2 intervals of time and between these 2 times and between other 2 times are different. And average velocity between any 2 times may not equal to any instantaneous value even, or at any particular point may even equal. That means, let us see, suppose if we consider this point, instantaneous velocity means slope of this tangent. If we consider these 2 points, suppose if this line is parallel to this line, so slope will be same. So I can conclude that average velocity between these 2 times is the same as instantaneous velocity at this time. So may be equal, may not be equal, and instantaneous velocity from this point to this point changes. Average velocity for this interval of time and for this interval of time is different. Okay, this is what we can conclude, but its motion is along positive x-axis because velocity is positive. Next, here Vt graph, what we can understand, when t equal to 0, velocity is 0. So initial velocity of the object is 0. And we have this graph only for positive values of velocity. So its motion is along positive x-axis. Next, instantaneous acceleration is equal to dv by dt, or it is also equal to tan theta. That means slope of tangent drawn to Vt graph at particular time gives you instantaneous acceleration, and it is also equal to tan of angle made by that tangent with the time axis. Suppose if you take this point, you draw a tangent at this point at this time and calculate the slope of this tangent. At this time also you draw a tangent and calculate the slope of that. So this slope and this slope is same because they are part of this straight line. Straight line slope does not change if you consider these points or these points. So what I can say here, acceleration value is constant. Acceleration value is constant. So that means acceleration is positive, one thing, because slope we are getting positive value, and its direction of motion is along positive x-axis. And the second thing is, at this instant acceleration value is constant, magnitude is constant. So acceleration value at each and every instant of time is constant. So I can